Okay, geometry folks, there are two triangles, two types of triangles that are so special to us that we take the time to memorize how the side lengths are related in that particular type of triangle. Remember that anytime you have three angles the same, then those two triangles are going to be similar. So every other triangle that has these three angles is going to be similar to this triangle. So that's true for, it doesn't matter what the three angles are. So I could memorize the ratios of the side lengths of any particular triangles, like maybe 70, 20, 90 triangles, or 30, 70, 80 triangles, or any combination. But we don't. We only do it for these two special right triangles. And the reason these two are special is just because these two triangles, 30, 60, 90 right triangles, and 45, 45, 90 triangles, which are also considered right isosceles triangles because the two angles are the same, because the two sides are the same, and vice versa. If you have two angles the same, you have two sides the same. If you have two sides the same, you have two angles the same. Isosceles base angles theorem is what that comes from. So basically a right isosceles triangle is a 45, 45, 90. But the reason we take the time to memorize how the side lengths are related on these two is just because these two triangles come up a lot in other shapes and in other contexts, including trigonometry. So today in class we talked a lot about 30, 60, 90s. We did not talk much about 45, 45, 90s. So I wanted to tell you a little bit more about those. We did a warm-up where we were finding the missing sides of triangles using the Pythagorean theorem. And in our warm-up, we had one triangle, oh, I can't find it, so I'm going to just redraw it real quick, that looked like this. And my triangles are not having the most straight sides. Sorry, I'm kind of off. Look like this. And we were supposed to use the Pythagorean theorem to find the missing side, which is the hypotenuse of this triangle. So this is a leg, this is a leg. Remember, the two legs meet at the right angle. And this is the hypotenuse. And when you do that, 3 squared plus 3 squared, leg squared plus leg squared equals hypotenuse squared. 9 plus 9 is 18. Take the square root of both sides, and we have the hypotenuse is the square root of 18, which is 9 times 2. So this becomes 3 root 2. So that's what we got. And basically that shows us the pattern that will always happen when we have an isosceles right triangle or a 45, 45, 90 triangle. Notice these two sides are the same. So both of those are legs. This is a leg and this is a leg. And in an isosceles right triangle, the two legs are the same. So it doesn't really matter which leg you're referring to when you mention the leg, they're the same. Either way, that leg times what gave me the hypotenuse? Times square root of 2. And that will always be the case. I could prove it to you pretty easily, in fact, but I'm not going to right now. We might talk about that tomorrow in class. Basically, if you want to try proving it to yourself, use the Pythagorean theorem and call the two legs x or a or something else like that. And you'll see that you will get a times square root of 2 for the hypotenuse. Okay, so let's do some examples with 45, 45, 90. So let's just talk about this again. Here's the sort of official picture you might want to copy down. The two legs of a 45, 45, 90 are always going to be the same. The hypotenuse is always whatever the leg length is, so I called it x, times square root of 2. So the special number, the number that sort of signifies the relationship between the legs and the hypotenuse of a 45, 45, 90 is square root of 2. If you're going from the leg to the hypotenuse is the biggest side. So you're trying to get bigger. You multiply by square root of 2. If you're going from the hypotenuse to the leg, hypotenuse is the biggest, so from here to here I'm going smaller. So then I would divide by square root of 2. So another visual that can help you sort of see this is if I'm going from here to here, I multiply by square root of 2, and from here to here, I divide by square root of 2. And the same goes for this leg down here. Okay, so let's do some practice problems. First one. First thing I need to do is recognize that it is a 45, 45, 90. There are several different ways I can be told I have a 45, 45, 90. This time I was shown one of the angles, one of the two acute angles. If I have 90 and 45, this one has to be 45, so that's a 45, 45, 90. Okay, so first thing is recognize it. Second thing is figure out which side you have. Figure out which side you're dealing with, which side you were given. So the two legs are the ones that meet at the right angle. So this is the hypotenuse. So I was given the hypotenuse this time. And the relationship between the hypotenuse and the legs is square root of 2. And since I'm going from bigger to smaller, I'm going to divide by that. Easiest way to write it is just on top. 10 divided by square root of 2. Now you're not allowed to leave a radical in the denominator ever. So we have to rationalize that. So to get a radical out of your denominator, you're going to multiply by something over itself. In other words, I have to multiply by some form of 1, but the thing I'm multiplying by is going to make that denominator no longer under a radical. Square root of 2 times square root of 2 is 2. On the top, I get 10 root 2. This can be simplified further because 10 over 2 simplifies to 5 over 1. So that is the leg length in my 45, 45, 90 triangle. Next one. Okay, this time I was given what? First of all, I was again just told by the angles. Another way you can be told is if you had congruent angle marks. That would tell you it was a 45, 45, 90, or a right isosceles. Okay, so I was told this is 45. Where's the hypotenuse? Where are the legs? Well, the legs meet at the right angle. So this is a leg and this is a leg. So I was given a leg. That means this is the hypotenuse. So to go from a leg to the hypotenuse, we're still going to use square root of 2, but we're getting bigger. We're trying to go for the bigger side. So 12 times square root of 2. And really that's all I need to do. 12 root 2. Well, what about this other leg? Well, it's the same. Remember, the two legs are the same. So it's just 12. Okay, last example. Here's another way of showing me that I have a 45, 45, 90, or right isosceles, is to mark the two sides the same, the two legs the same, that tell me it's an isosceles triangle, and since there's a right angle, it's automatically a right isosceles. Okay, so I'm given here what? Well, this is a leg, this is a leg, so there's a hypotenuse. I'm given the hypotenuse and I need to get the leg. The only number you ever use with a 90, 45, 45, 90 is square root of 2. That's the only number I need to remember, square root of 2. So I'm going to have to do something with square root of 2 here. And I'm going from the bigger side to the smaller sides. I know this is bigger because it's the hypotenuse. So that means division. So division by square root of 2 here means this, which means 8. So both of those legs are 8. And that's how you do it.